Hello, and welcome to another digital lecture for Salt Lake Community College. In this lecture, we would like to summarize some of the procedures we have used in our class. We have used procedures to estimate parameters, test claims, and make predictions. An important skill for us is to know when to apply each procedure. In this first table, we are presented with each procedure, the type of data it would apply to, and the type of research question we may wish to ask. For example, if we are given one categorical variable, such as the proportion of people that are left-handed, and we wanted to estimate this parameter, this proportion, P, then we could use a one-sample Z confidence interval for a proportion. However, if we wanted to test a claim about this parameter, about this proportion, to see if this proportion is less than some value, greater than some value, or just not equal to some value, then this is where we would look at a one-sample Z test for a proportion. On the other hand, if we're given a quantitative variable, such as the distance that SLCC students drive to get to school, notice that the distance, a quantitative variable, could be represented by mu. And if we wanted to estimate this parameter, the mu, this is where we would use a one-sample T confidence interval for the mean. However, if we wanted to test a claim about this parameter, about the mean distance that students at SLCC drive to get to school, then this is where we would look at a one-sample T test for the mean. It's important to notice that if we're talking about estimating a parameter or testing a claim about the mean, this is when we either use a T test or a T confidence interval. But if we're estimating the parameter P or testing a claim against the parameter P, the proportion, this is where we would use a Z test or a Z confidence interval. Yeah. Or we could be given two variables, a categorical explanatory variable and a quantitative response variable. Notice that your response variable, being quantitative, would be something about your mean. So if we were talking about people that work from home and people that work from your company office, these would be your categorical explanatory variables. And maybe your quantitative response variable would be the number of hours that they work. So if you wanted to estimate the difference in these parameters, if you wanted to estimate the difference in the mean number of hours worked from home and the mean number of hours that you work from your office, if you wanted to estimate this difference, this is when you would use a T confidence interval for the difference of means. However, if you wanted to test a claim about the difference in the mean number of hours worked in the office versus working at home, this is when you would use a two-sample T test for the difference of means. And again, notice that because we're talking about estimating a parameter or testing a claim about the means, this is when you would use either a t-test or a t-confidence interval. Now again, if you're given two variables, maybe again your explanatory variable is categorical, but now also your response variable is also categorical. Again, if we're thinking about, people working from home or people working from their office, maybe your categorical response variable could be if they're happy with their jobs. And so we might be estimating the difference in the proportions of people that are happy working from home and the proportion of people that are happy working from their office. And if we wanted to estimate the difference in these proportions, this is when we would use a two-sample z confidence interval for the difference of proportions. While if we wanted to test a claim about the difference in the proportions of people that are happy working from their office or working from home, this is when we would use a two-sample z-test for the difference of proportions. And again, notice that because we're talking about estimating the difference of proportions or testing a claim about the difference of proportions, this is when we use a z-test or a z-confidence interval. The last example we have is if you're given two variables, maybe a quantitative explanatory variable and a quantitative response variable. An example might be, considering the weight of your car and the gas mileage you get. We might want to use the weight of your car to predict the gas mileage that you might get. In which case, you're looking at the relationship between these two quantitative variables, and you might want to look at performing a linear regression to find that relationship so you can use one variable to predict the other. Now, in the second table that we are given a list of research questions that you might be interested in. And we are being asked to identify which procedure would be most appropriate to answer the research question. Now, I think it would be a good idea if you paused the video here for a moment and took time to read each of these research questions and come up with the most appropriate procedure that we would apply. After you've considered each of these different research questions, unpause the video and come back and we'll discuss them. I'll see you in a little bit. Okay, let's take a look at each of these examples. I hoped you paused your video and considered each of them on your own, but let's do these together now to see how we do. In our first research question, we're asked to estimate the mean height of SLCC students. Notice that the mean height is a quantitative variable, and we're being asked to estimate this quantitative variable. To estimate a quantitative variable, we would use a one-sample t confidence interval for the mean. And it's important to notice that whenever we want to estimate a variable, this is always going to be when we use a confidence interval. But because ours is a quantitative variable, that's why we're looking at a t confidence interval. Second question. Can GPA be used to predict starting salary? In this question, notice that GPA and starting salary are both quantitative variables since they take on numerical values that can be added and subtracted in meaningful ways. And we're being asked if GPA can be used to predict starting salary. And because we're trying to be using one quantitative variable to predict another, this is when we would want to perform a linear regression. The next research question. Is the proportion of SLCC students who receive financial aid higher than 50%? So notice that we're given a proportion, the percentage of students that receive financial aid. And we're being asked, is this proportion higher than 50%? Here, we're being asked to test a claim, if it's higher than 50% or not. And so we would look at a one sample z-test for a proportion. Again, it's important to notice whenever we're being asked to test a claim, this is when we're looking at a z-test or a t-test. But because this research question is talking about a proportion, that's why we choose to use a z-test. Let's look at our next research question. Is the graduation rate higher for traditional students at SLCC than non-traditional students? Notice that we're being asked a question. Is the graduation rate higher? We're being asked to test a claim about two different proportions, traditional students versus non-traditional students. And because we're asked to test a claim about two different proportions, we'll look at a two-sample z-test for the difference of proportions. Our next question. Do SLCC students drive faster than 15 miles per hour in the parking lot? So again, notice we're being asked to test a claim. Do they drive faster? And we're looking at a quantitative variable, the speed that they drive. So because we're being asked to test a claim about a quantitative variable, we'll look at a one sample t-test for the mean. Our next research question. What is the difference between the mean number of credits for SLC students in the School of Business and the School of Health and Sciences? Here we're being asked, what is the difference? We're being asked to estimate the difference between these two means, the mean number of credits for students in the School of Business versus the School of Health Sciences. And because we're trying to come up with this difference, we're trying to estimate a value, so we will use a two-sample t confidence interval for the difference of means. Our next research question asked, is the mean number of hours worked per week lower for full-time students than for part-time students? Here we're being asked, is the mean different? We're being asked to test a claim about the mean number of hours for full-time students and for part-time students. Because we're being asked to test a claim about the mean number of hours between these two different groups, we will look at a two-sample t-test for the difference of means. In our next research question, we're asked to estimate the proportion of SLCC students who transfer to a four-year university. Notice again that we're asked to estimate a value. So we know we're going to be looking at a confidence interval, but we're being asked to estimate a proportion. So we would look at a one sample z confidence interval for proportions. Our last research question asked, what is the difference between the percentage of students who pass Math 1040 and the percentage of students who pass Biology 2320? Again, here we're asked to find the difference or estimate a value. And we're being asked to estimate this difference between the percentage of students who pass 1040 and the percentage that pass Biology 2320. These percentages are proportions. And so we're looking at estimating the difference between two proportions. So we would use a 2-sample Z confidence interval for the difference of proportions. This is a pretty good list of different practice problems that will give you an idea how to determine which procedure to use to answer each question. However, if you have further questions still, be sure to review the example videos that follow or ask your instructor.